Good morning. I am going to talk through the notes, the 11.3 part 2 notes with you right now. Today is the last lesson that is on your quiz next week. You have a quiz next Tuesday. And remember, this part of the unit is dealing with the areas of different shapes mainly. So today we're doing the areas of regular polygons. So the first thing on here is just a box containing some vocabulary that will be important to you. So just a reminder of what a regular polygon is. A regular polygon is a polygon with all sides and interior angles, they're equal. So this should say equal. So here we see a regular polygon inside of a circle, just to kind of help us understand some of the vocab a little bit more. So now, we are going to talk about some vocab that we will be using a lot today. The first word is the apothem, is how you pronounce that. So this word right here. We use a lowercase a for the apothem. It's the distance from the center to the middle of a side of the polygon, and it's always perpendicular. So pick a side of the polygon, doesn't matter which side, and then just draw this distance, and it's always at a 90-degree angle. That's the apothem, so that has an A on it. The radius is the distance from the center to a vertex of the polygon. In other words, an angle of the polygon. So we know what a radius is, but we think of a radius more with like just the circle. But in this case, the radius, we can see the radius of the circle would actually be equal, but it's the distance from the center to a vertex of the polygon is our radius. The central angle of a polygon. So the central angle of a polygon, you want to think about the fact that when we have a polygon like this inside of a circle, what we really have are a lot of different triangles, and those triangles are going to be very important to us in this lesson. Those triangles are also all congruent. So the central angle is going to be this angle. I'm trying to mark it on the diagram. Any of these angles, and they're all going to be the same. It's going to be 360 divided by the number of sides that the polygon has. So this is 360 divided by n, where n is the number of sides. So for example, if it has 6 sides, each of those angles would be 60 degrees. So now, we're just going to make sure we understand the vocab and then actually do a little bit of math with some angles. So this says name the apothem. So just making sure you understand that vocab word. Again, remember it's the distance from the center to the middle of one of the sides, and it's going to be perpendicular. So JK is our apothem here. And that's the only apothem showed in this picture. Name a radius. So a radius is going to be the distance from the center to any of the angles of the polygon. So JE would be a radius, JG or JH. Any of those would be fine. I'm going to go with JE on here. Find the measure of each angle. So when we are doing the measures of angles, we're looking at the same picture. So angle GJH. I'm just going to kind of erase some of my drawing on here. GJH would be this angle right here. That is a central angle. Central angle of a polygon is going to be 360 divided by the number of sides that the polygon has. And if you count, this polygon has 8 sides. So 360 divided by 8 is 45 degrees. So that angle is 45 degrees. The next one says the measure of angle GJK. So angle, let's find that angle. Angle GJK is this angle right here. We can tell that that angle would be half of the orange angle. So it's just half of my previous answer. Oftentimes in this lesson, we'll find ourselves cutting that central angle in half because we want a right triangle, which I'll talk more about on the next page. But 45 divided by 2 is 22.5 degrees. And then the last one is the measure of angle KGJ. So KGJ. So KGJ is this angle that I'm marking in blue. This triangle is kind of tiny, so it might be a little bit hard to see, but we know that a triangle always adds to 180. I already have a right angle right here. So to get that angle, I'm just gonna take these two acute angles, as in the blue and the like pinkish one, have to add to 90 because 90 degrees is already taken up by that right angle. So we're just gonna take 90 minus our answer to the previous problem, which is 22.5. So 90 minus 22.5 would be 67.5 degrees. All right, now we're actually getting into the formula that's kind of the main point of today, the area of regular polygon. This has to do with the fact that any of these regular polygons, it doesn't matter if it has 8 sides, 6 sides, 10 sides, 13 sides, any number of sides, you can always split it into that many triangles. And what happens is when you add all the areas of those triangles together, you come up with the fact that the best way to find the area of these shapes is to take half times the apothem times the perimeter. And that kind of just adds the areas of all those triangles together. So the important measurements that we need to have are the apothem and the perimeter. And if we don't have those, we have to go through the process of finding them, which we will talk about as this lesson goes on. So here we're finding the area of each regular polygon. So it's a regular polygon, means all the sides are the same. This one happens to be a regular triangle, which normally when I see a triangle, I think half base times height. But we actually don't know what like the height of this triangle is. We don't know how big that part is. So that's not an option to us. So we want to use the formula that we're dealing with today, which is half apothem times perimeter. So 1/2. The apothem is right here. Remember, the apothem is the distance from the center to the middle of one of the sides. So the apothem is 7. So this is my A value. I'm just going to label it. So the apothem is 7. And then the perimeter, this has 3 sides. So the perimeter would be each side length, which is 24.2 times 3. So this is times 3. So 24.2 times 3. So half times the apothem times the perimeter. Type that in the calculator. I'm just going to put parentheses around that. And then just keep in mind, this dot right here is like a times. It's not a dot. It's not a decimal place. So I'm typing right now 1/2 times 7 times 24.2 times 3, and I'm getting 254.1. And that is feet squared, or square feet. On the next one, it's another regular polygon, so all the sides are the same. It looks like, again, they give us all the information we need. So we're just going to do 1/2 times the apothem times the perimeter. So this 16 is my apothem. It's the distance from the center to the middle of one of the sides. So my apothem is 16. So we're going to go 1/2 times 16 times the perimeter. Each side is 13.3, and then we just want to count how many there are. Sometimes I like to highlight them as I count them just so I don't forget anything. 1, 2, 3, 4, 5, 6, 7, 8 sides. So it'd be 13.3 times 8. Keep in mind that's a times 8 when you're typing it in the calculator, not a decimal place. So I'm typing 1/2 times 16, and then I'm actually typing it exactly how it looks on the screen. 13.3 times 8. 851.2 centimeters squared. So that is that answer. Now, normally we don't have all of the information we need. So this next page is talking about how to deal with that when you don't have everything you need. So to find the apothem and or the side length, you want to create a right triangle by drawing the apothem and the radius. So what happens is, and we kind of did this on the first page, but this is the apothem and this is the radius. And then we can always find this angle by taking 360 divided by the number of sides, and then we actually have to take half of that, which I'll show you on the picture. Then you want to use the Pythagorean theorem or SOHCAHTOA. And then once you find the information that you need, you do 1/2 times the apothem times the perimeter again. There's a little tip here to keep at least 4 decimal places when doing your work. Don't round until the very end, just so that it's as accurate as possible. So on these examples, they don't directly give us everything like the other one did. So when I'm looking at these problems, it says find the area of each regular polygon. whatever kind of regular polygon it is, you need to know the apothem, which in this case we do know the apothem, and you need to know the perimeter. Well, at this point, I know nothing about the side length, but I can figure it out using the Pythagorean theorem. So with this triangle, I'm going to call this bottom part x, and I'm going to do the Pythagorean theorem to find x. In the calculator, I'm typing 8 squared, which is 64, minus 6.5 squared, because I'm trying to solve this, and I'm getting x squared equals 21.75. Then I want to square root that. So square root of that is 4.6637 approximately, if you round it. That's the x value. So think about the fact that that's this. Well, the side length would have to be double that. So this whole side would be double that. So let's multiply that by 2 in the calculator. I'm just using the previous answer on the calculator, which is always more accurate than typing in the rounded version. So I'm getting that the whole side length is 9.3274 to use 4 decimal places. So now we have everything we need because we have the apothem. It was given to us. We can find the perimeter because we know the side length and we can just count the number of sides. So we're going to do 1/2 times the apothem times the perimeter again. The apothem is 6.5. The perimeter is that 9.3274 that I got down here for like the side length, 9.3274 times 5, because this has 5 sides. And they're all the same if it's a regular polygon. Keep in mind that's a time, so I'll make it look more like the times on the calculator. I'm just typing that exact thing in the calculator. So I'm typing in 1/2 times 6.5 times, I'm going to use the previous answer button rather than typing in that 9.3274, and then times 5. 151, it says round your final answer. It doesn't say how many decimal places we should round our final answer to. I'm just going to put the nearest tenth. It actually round up 0.6 according to what I have. We have no units. So keep in mind that's an area, so it's square units. Okay. On the next one, we have another situation where we're not necessarily given much information. I see a hexagon. It has 6 sides, and I only have the apothem. But we can still find the area of it using trig. The Pythagorean theorem for us is not going to be an option here because I only know one side of this triangle. So I'm going to need to get that angle and then use SOHCAHTOA. So this angle that I'm pointing at with an arrow, the central angle would be 360 divided by 6. But keep in mind that central angle is this like whole, like the green one is 360 divided by 6. So that's 60. So therefore this half of it is going to be 30. Kind of just writing down what I'm saying. But you want to understand that this angle is going to be 30. So I'm just going to go back and kind of erase some of my markings here because there's a lot of math going on. This is going to be 30, which means this is a 30, 60, 90 triangle. You don't need to use those rules unless you remember them. I'm actually going to use SOHCAHTOA to find the side length. So let's call this x over here. In relation to this 30-degree angle, this is opposite, so x is opposite. This 5 is adjacent, so that's tangent. So you want to say tangent 30 equals opposite, which is x, over adjacent, which is 5. Multiply by 5 to solve that. Type 5 tan 30 in the calculator. First, whatever calculator you're using, make sure it's on degree mode. So 5 tan 30. I'm getting 2.886. That would actually round to 8. So that's x. Keep in mind when you look at the picture again, you can hopefully tell that like what I need is that side length, which is going to be double that. So I'm multiplying it by 2, and I'm getting 5.7735 is the whole side length. Now that's everything I need because I was given the apothem and I can find the perimeter. So just plug into your half apothem perimeter equation again. So half, the apothem is 5. The perimeter is that 5.7735 times 6, because this has 6 sides. I'm going to, again, use the answer button on the calculator, which will be a little bit more accurate than rounding it. And I'm going to get, sorry, I typed it wrong. Retyping it. 86.6 approximately. That's square meters. Okay. Now, on the next page, there's a few more examples of this. So turn to the next page. Just more scenarios where we definitely don't have very much information and just talking about how to deal with it. So here we only have one piece of information that's directly given to us, and it's just the side length. So I'm missing that apothem. I have the information I need to get the perimeter, but not the apothem. So drawing my triangle. This top angle is going to be 360 divided by the number of sides. Again, sometimes I like to mark them while I count them. 1, 2, 3, 4, 5, 6, 7, 8, 9 sides here. 360 divided by 9 is 40, but that angle is always half of that. So this angle is actually 20 degrees in this triangle, so that top angle is 20. Now I want the apothem, so this is my A. Understand in my triangle, this side length that I want of this triangle is actually 3. So cut that 6 in half. So now in relation to that 20-degree angle, the 3 is opposite and the apothem is adjacent. So it's again going to be tangent, TOA. So we're going to say tangent 20 equals opposite, which is 3, over adjacent, which is the apothem. Multiply by A. So you have A tan 20 degrees equals 3. Divide by tan 20 to solve for the apothem. .2424 to 4 digits. Now do half times the apothem times the perimeter again. So it's half times the apothem times the perimeter, which is going to be 6 times 9, which is 54. But each side is 6 and there's 9 sides. Type that in the calculator. 222.5. Does this have a unit? Inches squared. It's area again. Now the next situation here is going to be just given the apothem. So we actually already did this on the previous page. The apothem was 5. Now we have a different thing here where the apothem is 7. So I'm going to go through it with you again. So the apothem is 7. So draw your right triangle. I'm going to draw this right triangle. Oh no, it's not the apothem. Oh, sorry. I just realized it's actually not the apothem. So the apothem connects the center to the middle of one of the sides. That's not the apothem. That's the radius. So here I know the radius is 7, so that's my R. So now I'm going to draw my right triangle. I need the apothem, so that's the apothem that I don't know. They're trying to tell me the radius is 7. So this angle up here is going to be 360 divided by the number of sides, which is 1, 2, 3, 4, 5, 6, 7, 8. 360 divided by 8 is 45, but then you need to cut it in half. So that angle is going to be half of 45, which is 22.5. I'm just going to redraw that triangle because I feel like it looks a little strange. So I'm kind of just redrawing it over here. So I just found that top angle is 22.5 degrees. The radius, which is always the hypotenuse of this triangle, is 7. They were trying to show me that was 7. I need the apothem. So this looks like an example of cosine. So we're going to say cosine, because cosine is adjacent over hypotenuse. So cosine 22.5 equals adjacent, which is A, over hypotenuse, which is 7. So multiply by 7. And then 7 cosine 22.5 is the apothem is about 6.4672 if we're rounding it. Okay, then I want to do the perimeter. I don't have the side length yet. So this A value is about 6.4672. I'm going to do the Pythagorean theorem to get this side length. So I have x squared plus 6.4672 squared equals 7 squared. I'm going to solve that on the calculator, which I know you know how, so I'm not going to show a lot of steps here. 6.4672 squared. So for my final answer, when I solve that, I'm getting x is about 2.6787. Okay, that is half of that side length. So multiply that by 2, and that's the whole side length. So the side length here is double that 2.6787. So it's about 5.3574 is my side length. So now I'm going to do half apothem times perimeter again. So half, the apothem is that 6.4672. Trying to zoom in here. 6.4672 times the perimeter. The side length is 5.3574, and there's 8 sides. Make that look like a times 8. Now it's just a matter of typing it in the calculator. Getting 138.6 approximately. And that would be millimeters squared. So within the context of this lesson, we're just trying to give you like every different scenario that you could deal with. So here we were just given the radius. Here we were just given a side length, etc. Sometimes they just give us an apothem. So here we're just given an apothem again. We have kind of already done just given the apothem, but I'm going to draw this triangle. This angle is going to be important to me. So the central angle is always 360 divided by the number of sides. There are 3 sides. 360 divided by 3 is 120. I think we can tell looking at that it's not an obtuse angle. So it's actually half of that always. So this is 60. So that's my angle. I need my side length, so this is my x. This is tangent. I have opposite and adjacent. The apothem is the adjacent. So I'm going to say tan 60 equals opposite, which is x, over adjacent, which is 18. Take 18 tan 60 and get about 31.1769. Double it to get the side length. So this whole side is 62.3538. Okay. Now I have everything I need. So it's half apothem times perimeter. Half, the apothem is 18, times the perimeter is that 62.3538 number, times 3 because it has 3 sides. Typing that in the calculator, I'm getting 1683.6 approximately, and it's millimeters squared. Just typing that one more time to make sure I did that right. Yep, getting the same answer. So that is that answer. So within the context of these notes, we have done every scenario that you could be provided with. So there are some U-tries on the next page. So what I'm going to say for the rest of this hour is the U-try, since I know sometimes some of you kind of work ahead, the U-try answer key I'll have it sitting on my desk with the sub. And then also the sub has your homework to pass out. So the homework will be passed out now. If you did any of the U-Tries and you want to check your answers, or if you want to see more examples, I will load the answer key to the notes on Google Classroom so you can check that out. For the rest of the hour, just work on the homework. I know this was not the easiest lesson today because you have to remember SOHCAHTOA, but I know you can do it. So just work for the rest of the hour, and then on Monday you'll get a quiz review. So I hope that you have a good weekend, and I will see you then.